Hi everyone, and welcome to this video about completing the square and using that to solve quadratic equations. Please remember to like and subscribe if you enjoy the video. Remember, you can always comment down below any questions that you might have, and if you would like me to make a video on any other maths topic of your choice, leave that in the comments section as well. The technique of completing the square involves taking our quadratic equation, turning it into a perfect square and another constant. What I mean by a perfect square is an expression like this, where we have x plus another constant all in a bracket squared. And of course, a constant is just any number like this. So the general form after we've completed the square is a brackets x plus b all squared plus c. In the above case, a is 1, b is positive 2, and c is minus 4. So after completing the square, your form of your equation should always be this yellow form here. So how do we get from a normal quadratic into this form? Well, let's take a look. Taking a look at this quadratic here, we can see that we're not able to factorize this expression. There's no way of splitting this up simply into two factors. The technique involves looking at the first two terms to begin with. Our goal is to recreate x squared plus 4x, but our starting block must be a perfect square bracket. I'm just going to write out this square bracket as two brackets multiplied together. And inside of these brackets, I'm going to put x plus 2. And the reason I'm doing this is if we expand this out, we would get x squared plus 4x plus 4. We can see that at least part of my current expression is what I want in x squared plus 4x. However, we have this extra term plus 4 at the end. So if we only want x squared plus 4x, I now need to subtract away 4 from this expression in order to just leave x squared plus 4x. Let's ask ourselves the question, what is equivalent to x squared plus 4x? Well, we can see that these three lines of algebra are all equal to each other. I wanted a perfect square form, remember? So a bracket squared. And if we look at that first line, we do in fact have a bracket squared. So x plus 2 squared minus 4 is equal to my x squared plus 4x. Let's think of an easier way to think about the method, because that's a lot of steps to go through when we're doing a question. What I've done is I've taken x and placed it at the front of my bracket. Then I've looked at the coefficient of just the x term, and I've halved that coefficient and placed that in the bracket. We can see that this is because when I'm expanding my bracket, I'll be doing 2x plus another 2x. So that 2 must be half of the coefficient of the central term. So the bracket is very simple. We take x, and then we place half of the coefficient of x in the bracket with x. So that's how we get the square bracket. Then we need to balance out the remaining constant. In the case of x plus 2 squared, we would get x squared plus 4x, but we would have this extra plus 4 at the end once I've expanded out. So in order to get rid of that, I need to minus 4. So the expression ends up looking something like this. You can try expanding that out in order to check if it is indeed x squared plus 4x. So once we've completed this step, we can now return to our original quadratic and replace x squared plus 4x. So I'll replace that with x plus 2 squared minus 4. And you can see that I've still got this extra constant of minus 3 at the end. So I'm going to subtract that away. And then simplifying, I get x plus 2 squared minus 7. We can see that this is in the form that we want. We have a bracket squared, a perfect square, and then subtracting a constant. Comparing with the general form, a must be 1, b must be 2, and c must be minus 7. Let's just run through those steps again. So the first step is to write down my square bracket, place x at the front of that bracket. Okay, this is just to set up the general form of completing the square. So let's do an example side by side. This is the quadratic that I would like to complete the square on. My first step is to write down that square bracket and place x at the front. The second step then is to halve the coefficient of the x term, place that in the bracket that we've just written down. The coefficient of the x term is 4. I'm going to halve that. That becomes positive 2. So I place that in the bracket with my x. The next step is to expand this bracket, find the extra constant that it gives, and subtract that away from the bracket. So this step we normally wouldn't write down as equal to the previous step. This is just a little bit of working out that we're doing ourselves. So I'm going to do this in a different color. I'm going to expand x plus 2 squared, which is going to be x squared plus 2x plus 2x plus 4. Simplifying that then, we can see that our extra constant compared to x squared plus 4x is plus 4, so I need to subtract that away from my bracket. The next step is to bring down the constant in the question initially, so that was plus 5, so I need to bring that down to the next line because we didn't consider that yet. And then we need to simplify it, so we would have x plus 2 in a bracket squared plus 1. That is in completed square form with my square bracket plus a constant at the end. Let's take a look at an example together. I have my quadratic expression here. First step is to write down that square bracket, place x at the front. Then I'm going to look at the coefficient of my second term, which in this case is 5. So I'm going to add 5 over 2. Okay, so remember half of that second term in my bracket. Then I need to open this bracket out, expand it, and find what is the extra constant that I need to get rid of. In this case, expanding the bracket would give x squared plus 5x plus 25 over 4. We can see that the extra constant is this 25 over 4, so I need to subtract that away from my bracket in order for it to equal x squared plus 5x. Now the next step is to bring down the extra constant in the question initially, so that plus 1 there. Now it's time to simplify, and I get this as my final answer, with the final constant simplifying to minus 21 over 4. Let's quickly take a look at another example. First step, write down my square bracket, place x at the front. Second step is to halve the coefficient of the x term, which would give me minus 4. Then I'm going to do a little expansion. X squared minus 8x plus 16 is what I would get. Then I'm going to subtract away this extra constant of 16, bring down the extra constant in the initial question, and simplify my final answer as such. So in this example, something slightly different has happened. We have a number in front of my x squared. So the coefficient of x squared is no longer 1. So our technique doesn't change that much when we're dealing with a question that looks like this. There's just an extra first step and an extra last step that we need to think about. To simplify this completing the square step, I'm going to always take out the coefficient of the x squared term from the first term and the second term. So from that x squared term and from that x term. I'm going to factorize out the 4. So you can see I only factorize the first two terms, not the final constant term. Now I'm going to complete the square inside the bracket that I've made. So inside that bracket, I now need my square bracket, place x at the front, take half of the coefficient of x. Then I'm going to do my little expansion on the side, where I do x squared plus 3x plus 9 over 4. So after expanding that bracket, I find that the extra constant is 9 over 4, so I must subtract that away now. Then bring down the minus 5 from the previous line. Expand the 4 into this bracket now, into the larger set of brackets. So the way we do that is times the 4 at the front here, and times 4 by this number here. So I would get 4 brackets x plus 3 over 2 all squared minus 9, and then bring down the minus 5 as well. At this stage, all of these lines are equal to each other. The last step then is to just simplify that final constant, ending up with this as my final answer. So you can see that the extra steps was here, where I first factorize out the number in front of x squared from the x squared term and the x term. And the extra step that I do is multiplying in this 4 into this big bracket that I created. Okay, the other steps, as far as completing the square, balancing out that constant, are exactly the same. Let's look at another example then. In this case, I have -1 being the coefficient of my x squared term. So I'm going to factorize that out. -1 inside our bracket will be x squared minus 4x. Don't touch the final constant. The next step then is to complete the square inside the bracket I've made. So half of the coefficient of the x term would be -2. Square that, and if we do a quick expansion of that bracket, we'll find that it's x squared minus 4x plus 4. The extra constant that needs removing is 4, so -4 from that bracket. Bring down +1. Now it's time to multiply back in the -1 that I factorized out. So minus brackets x minus 2 squared plus 4 plus 1. And the last line combining those last two constants, x minus 2 squared plus 5. Finally, let's have a look at how we can solve a quadratic after we've completed the square. So this was one of my previous examples. I'm just going to rewrite the question as the quadratic set equal to 0. So we can't solve a quadratic unless it's part of an equation. Here we have our quadratic equal to 0. This is how you should rearrange it before completing the square. So after completing the square, we could write that brackets x minus 4 all squared minus 9 is equal to 0. We can do this because we worked out previously that if we completed the square on this, it would just equal this form here. So once we're at this stage, it becomes very simple. We just need to do the same thing to both sides of the equation and solve for x. I would first add 9 to both sides. The next step is to square root both sides of the equation. And this is the step that most people forget. This is a very, very important detail. When we square root both sides of the equation, we must remember to have a plus-minus sign on one side of the equation. So the answer on the right could either be +3 or -3. Both would satisfy the previous line of the equation, as +3 squared is 9 and -3 squared is also 9. Now I can add 4 to both sides. And we can see that the answer has to be 4 plus 3, so x equals 7, or the answer is 4 minus 3, x equals 1. Let's look at this example together. So my first step is to, of course, complete the square on this right-hand side, writing down the square bracket, and half of x's coefficient, which is 1. I can see that expanding this would leave me with the final constant of +1, so I need to subtract 1 at this stage, bring down the -2, and that is equal to 0. I can, of course, simplify at this stage and have this as -3. So now what I can do on both sides is add 3, square rooting both sides, and remembering that I must have a plus-minus sign on the right. And now square root 3, which I'm just going to leave in surd form as root 3. I can then subtract 1 from both sides of the equation, and these will be my two answers, -1 plus root 3 and -1 minus root 3. Let's look at solving this final example together. The first step, when we find the coefficient of x squared is not 1, is to factorize out that number from the x squared term and the x term. So we've brought down the -6 as well, not changed that, just factorized 2 out of the first two terms of my original quadratic. The next step is to complete the square inside the bracket that I've made. So taking half of the coefficient of x, in this case would be 5 over 4. And if I did an expansion of this bracket, it would be x squared minus 5 over 2x plus 25 over 16. So the extra number that I have is 25 over 16. Subtracting that away then from my bracket, bringing the 6 down, keeping that equal to 0. Now it's time to expand, so we can multiply the 2 into this big bracket now, which will look something like this. I can now simplify. So at this stage I can now add this fraction to both sides of my equation, then divide both sides by 2. No, I can't just square root both sides straight away. because I have this extra 2 in front of the square bracket. So I'm going to do that on both sides. Now I'm going to square root both sides, always remembering the plus minus sign before I square root my number. Then I can add 5 over 4 to both sides, giving me my final answer is 5 over 4 plus or minus the square root of 73 over 16. We can see that completing the square is a useful technique when we want exact answers for our quadratic. This third here is very complicated and is going to work out to be a long decimal. However, we can leave it in third form if we wanted to, or in fact we could put it into the calculator at this stage to work out our decimal answers. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.